Hello everyone, welcome to tutorial 11. Today's our first task is about power method. So we have to find the largest eigenvalue in magnitude and its corresponding eigenvector by using the power method. The matrix A is given to us and we have to start with the initial guess eigenvector, which is 1 minus 0.5 and 0.5. And we have to keep 3 digits after the decimal point in every step. So let's go ahead and get started. I've written down the matrix A and the initial guess x0 here down, and our first step will be to multiply A times the x0. So that will give us here A times x0, which is 1 minus 0.5, 0.5, and multiplying them both will give us y1, which is 4.5 minus 1.5 and 2.5. Now I hope you all know how to calculate this vector here. I'll show you for the first element here how to calculate it. So you have 4.5 here, which is multiplication of the first row times the first column here. So 4 times 1 plus we have 0 times minus 0.5 plus we have 1 times 0.5 here, 1 times 0.5. Okay, that would give us 4.5. Once we are done with finding out y1, what we do next is we take out the lambda as common, but before that let us decide which element will be our element of unity, which will always keep as 1. So for us, I would take the first element here to be always 1. So in that case, I would take that, to make that 1, I would have to divide it by 4.5. So I'll take 4.5 as common out, and that will give me 1 here, and minus 0.333 and 0.556 here. Now that's the first iteration. For the second one, we have now got this one here is x1 vector. So we'll multiply now A times x1. So we have A here times x1, that is 1 minus 0.333, 0.556 here, and that will give us 4.556 minus 1.444 and 2.556. So now to keep the first element as 1, we'll take out common 4.556, and that will give us, so when we take it out as common, what we do is we divide every other element here by this number here, right, the eigenvalue. So this will give us 1 minus 0.317 and 0.561. Okay, now we have got our, this one here is our x2. So we'll multiply A times x2. So that is, we'll take A here times x2, which is 1 minus 0.317, 0.561, and this will give us here 4.561, and then we'll have minus 1.439, and then we'll have here 2.561. Now to keep the first element here as unity, we'll take it out as common, so we'll have here 4.561, and then if you take that common out and you divide all of these elements here, dividing by this number, you will get one here, minus 0.316, 0.561. We'll continue doing the steps until we see that our eigenvector, this side here, this is the eigenvector, it is converging, until it converges. So now we'll multiply a times x3. So we have our matrix A here, times vector x3, which is 1 minus 0.316, 0.561, and that gives us the vector 4.561. And then we have here minus 1.439 and 2.561. So again, we'll take out the common as 4.561, giving us one here and minus 0.315 and 0.562. So we can see it's converging now here. Let's do one more step. So we have a times x4 now. So it is x4, yes. A times x4 is 1 minus 0.315 and 0.562. This gives us 4.562 minus 1.438 and 2.562. Now if you take out 4.562 common, we'll get here 1 minus 0.315 and 0.562. So as you can see here, we got the exact eigenvector like the previous step now we're here. So we have here 1 minus 0.215 and 0.562, and so goes here 1 minus 0.315 and 0.562. So it has converged, the eigenvector, and once it converges we can stop. Or in the final exam I could have asked you to do 5 iterations. So we have here 5 iterations done. I could say you to do 5 iterations, or I could say you until the eigenvector converges, carry on your steps here. So now we can say that the largest eigenvalue of matrix A is lambda is equal to 4.562. so this is our lambda here, and the eigenvector, or the eigenvector corresponding to the largest eigenvalue is the eigenvector, this one here. So that is 1 minus 0.315 and 0.562 here. And that's the end of task 1.